complex problems of nodal analysis. Nodes in this equation. Node because as this resistance, and this component is attached, so this we would name it as V1. Now let's see another node. This is another node. As this resistance, this is attached, and the three components attached, so it is also as node V2. We would give it name as this is also a node as 1, 2, and 3 components are attached to it, so V3. So this would be our circuit. Now this circuit could also be given it as to us by our examiners like this component is attached, this is attached, and this is attached, so this would we will give it as V1. This across this is that is V2 and V3. Okay, now so we will solve this equation because the examiner will give it the question as this, not as this. Okay, so let's solve this equation. We will apply KCL across V1. First we will apply KCL across V1. So we see that V1 minus V3 over 2, V1 minus V3 over 2, because what else is across V1? Yeah, here it comes, V1 resistance, V1 minus V2 over 1, and the current is going away from the node, and whenever the current is going away from the node, it is taken as negative at the other side, at the other side of the equal to. So this would become our equation number 1. Now we will find KCL across V2. So V2 over 3, first will come V2 over 3, and then V2 over minus V3 over 4, the second one, 3 over 4, and the third one, yes, V2 minus V1 over 1. Okay, and there's nothing like battery connected, so it will be 0. Okay, this will be our question number 2. Now we will find KCL across V3. So V3 minus V2 over 4, now V3 over 5, now V3 minus V1 over 2, and the current is coming towards the node, so it will be taken as positive. So here our 3 equations have been come. We will solve these 3 equations simultaneously, and the value of the V1, V2, and V3 will come.